Welcome to Integrate Android Apps with Google Assistant using App Actions. I'm Jessica, and I'm a Developer Relations Engineer for Google. App Actions is how developers can integrate Google Assistant into their Android apps. With App Actions, users could jump right into the most interesting and useful points in the app with simple voice commands. Users could say something like, "Hey Google, order a pizza from example app" to the assistant, and the Android app will open to the correct section so then the user can start their order. You can think of this experience as having two parts. The first part is processing the user's input and understanding their request. The second part is fulfilling the user's request. Do you have an Android app that exploits its activities by allowing other on-device apps to invoke that export activity? Assistant may be able to automatically use these intents to bootstrap your app's support for assistant queries. Try it out. Just tell an assistant-enabled device, "Hey Google, open," and then your app name. Great, if it worked, fantastic. You can override this behavior and add more customization by using App Actions. And if it didn't, don't worry. You can still use App Actions to give users the functionality to use their voice to invoke your app. So let's dive into how App Action works. When the user says, "Order a pizza from example app," Google Assistant will process the user's input using natural language understanding, or NLU for short. Assistant will figure out what the user wants to do. Then the app is triggered with the data and opens to the section to start a pizza order. With that as our high-level scaffolding, let's go over all the things you need to know about building for App Actions, starting with building your first one, testing it, and learning how to release it out to the world. Then we'll go over different options for building and re-engagement. But before we dive in, let's root this in a concrete example. Let's say we have a to-do Android app. This Android app allows users to add items to a to-do list and mark them when they're completed. So a fairly simple to-do app. The first step in building is identifying your app's functionality and expressing that to the assistant. Think about what your app does and what type of functionality it supports. Is it a game app? Does it have a leadership board? Does your app track workouts? How about searching and viewing news updates? For our example to-do app, it can list out tasks by completed and active tasks. Now let's check out how to communicate this to the assistant. A key concept in machine learning and NLU is intent matching. Intent matching loosely means identifying several speech patterns for a particular functionality or intention of the user. Assistant has identified and supports over 60 different intents, which we call built-in intents, or BIIs for short. These BIIs are also arranged by several categories. Google builds and maintains the language models for BIIs to understand many common variations of queries related to that particular intent. But what if you have a use case that isn't covered by the dozen of BIIs that we support? There are custom intents just for that use case. Custom intents are similar to BIIs, where they communicate to the assistant what type of functionality you support, but they need more effort on the developer end due to the complexity of NLU. We highly recommend using BIIs first, and we'll talk more about custom intents later. So, out of all the categories, we highly recommend starting with the common built-in intents. These are over 10 BIIs that handle intents that apply to the majority of apps. You can almost certainly find something here that works for your app, like the Open App feature. The Open App feature BII helps users navigate to features within your app, which might be otherwise difficult to find or require multiple taps to get there. Let's go back to how App Actions work. So the NLU that Assistant does will process the user's input and match the user's intent to a BII. Going back to the fictional to-do app, we can use the Open App feature to display completed tasks and active tasks. This will open the app to filtered view, displaying only the tasks the user want to see. But how does Google Assistant know which features you support and how to match them, since not all apps use the term active or completed? Well, some BIIs use inline inventory. Inline inventory functions like a lookup table for BII parameters, expressing the variety of ways users refer to features or content in your app into item identifiers that you define. You'll need to define the exact set of words in the inventory that you want a system to look up in your user's requests. These options are declared statically in your app's configuration. A unique identifier for the option is received at runtime as a parameter of an incoming BII. Let's walk through how this is done. So here we have a user saying, "Hey Google, open to do and show me my active tasks." A system will match the open app feature BII and extract active tasks as feature. Feature is a parameter supported by the open app feature BII. And then in your inline inventory, it'll look up the value active tasks in your app's configuration and return the unique identifier of active. Finally, triggering your Android app with the open app feature BII capability to set the fulfillment with the parameter feature value of active. We've identified what you'll want to use for the open app feature, and that we'll want the features to be active and complete. To add these elements to our Android app, we'll need to add capabilities to our shortcuts.xml file. Capabilities are an expression of relevant feature of an app and contains a BII and its fulfillment instructions. Capabilities live in the shortcuts.xml file. And here we have a capability that is tethered to the open app feature BII, and our inventory parameter is called feature. To list out what possible values for feature, like active and complete, we'll need to add a shortcut. Within the shortcuts tag, you can add a shortcut for each type of feature. Here we have a shortcut for the active feature. It includes a capability binding tag to the open app feature BII. This tethers the shortcut to the open app feature capability declared previously. Finally, we have the parameter binding tag to an array resource that lists out all the synonyms for the term active. And here is an example of the array resource with a list of synonyms of the term active. It's important to try to capture all the possible synonyms since Assistant treats this as a lookup table. To capture complete as its own feature, you'll need to add another shortcut with its completed task information. Here is a reduced version of the capability and the two shortcuts. Great. Now we need to tell Assistant what to do when the BII is matched. Now that we have the BII and the inline inventory for feature in place, we'll need to add our intent tags to the capability. The intent tag contains the instructions on how to build the Android intent that will be delivered to the app in order to launch it. So the parameter tag actually lives inside the intent tag. Note that the naming of parameters between capabilities and shortcuts are important. The capabilities Android name has to match the shortcuts parameter binding Android key. Here, we're instructing the assistant to take the parameter name feature from the BII and copy it to the intent extra named as feature param. Here is an example of how the To-Do app uses the value of the open app features feature param to filter the list of to-do items by active. Great, we did an implementation using static shortcuts that uses inline inventory to tell Assistant about the things you needed to recognize. But there are times when the list of things vary based on users' behavior. This is when you can push dynamic shortcuts to tell Assistant about them. Dynamic shortcuts let users jump into a personalized place or bit of content in your app based on their past actions or behaviors. So these shortcuts are created at runtime and are personalized to the user. Also, during contextually relevant times, Assistant can proactively suggest your Android dynamic shortcuts to users, displaying them in Assistant-enabled devices. So going back to our example, To-Do app, a use case for dynamic shortcuts could be that every time the user creates a new to-do item, you can push that as a shortcut linked to a get thing BII with the name of the user gave to that item. So they can call it up whenever they want using that same name. So before implementing dynamic shortcuts, the BII for get thing and fulfillment needs to be established first. So here is a capability with the get thing BII. And similarly to the open app feature, the get thing has a parameter called thing.name. And here's the fulfillment. And the Android intent is managed similar to the Open App feature, where the Android app gets the value of getThing by accessing the key parameter from the extras. Great, now we have a working capability for getThing. Now let's make it dynamic. To create and push dynamic shortcuts, first you'll need to add these two Jetpack library dependencies, the Jetpack Core Capability Library and the Google Shortcut Integration Library. Then you can create the shortcut using the shortcuts.infocompact.builder class. The new shortcut will need properties like ID of the shortcut and labels. It'll also need capability binding, which is, of course, to the getThing BII we created earlier. Then push the static shortcut using the shortcut manager compact.pushDynamicShortcuts method. That's it for building our capabilities and shortcuts. Now let's test this out. First, you'll need to install the Google Assistant plugin from the plugin marketplace. After the plugin is installed, now you could use the App Actions test tool. With the emulator app installed, open the App Actions test tool and then create a preview. Then you can select the BII you want to test for. For our to-do app, what we're going to use is the Open App feature and change the feature's value to active. Then run App Actions, which will open the to-do app to active tasks. So normally, Assistant gets a hold of an app's App Actions configuration at the time it's uploaded to the Play. It's extracted the resources from the bundle and reads itself on the back end to listen for the BIs for the configuration. This test tool preview is a temporary backend configuration that tells the assistant about App Actions configuration to be used for a specific app for a specific Google user account without having to upload the app to Play after the initial upload that proves the developer owns the app. Now that it works, next is to request a review and deploy. Before submitting your newly uploaded Android app to Google Play console, you'll need to accept the actions on Google's terms of service under pricing and distribution. The App Actions review does not affect your Android app review and the deployment status in Google Play. So after it's approved, the app action will be available to users of your published or open test releases. And that's it for building, testing, and releasing your app actions. Now let's move on to other elements that you can do, starting with custom intents. So custom intents are similar to BIIs, but they need more support on the developer end. Here's an example of a custom intent. First, custom intents need query patterns. Query patterns are examples of different ways a user can ask for a particular functionality. Let's say I have a cake making app and I want to give my users a way to say, hey Google, open baking fun and start baking cupcakes. Well, I would need to provide several different ways a user might say something like that, like craft cupcakes or produce cupcakes. Again, really similar to BIIs, custom intents also pass parameters. So you can have users say something like start making 18 cupcakes, and you'll be able to access the number 18 and be able to provide your users with instructions for making the 18 cupcakes instead of the usual 12. We recommend using BIIs over custom intents because of all of this additional work. Now, widgets. You could utilize widgets as a way to fulfill a user's query, leveraging your existing Android widgets. That means instead of having the app open up, the response will appear inside Assistant. Users can also pin the widget to their home screen. You'll also need to provide text-to-speech, or TTS, for the widget, since the Assistant provides audio responses. Using widgets is great for situations that require a short and simple response. Since they appear inside Assistant, widgets are great for hand-free contexts, such as when the Assistant provides information on a lock screen or on Android Auto. Now to in-app promotion. For your most critical user journeys, you can suggest to your user to create Assistant shortcuts in your app, which is a phrase that triggers a particular shortcut. This is similar to how Assistant shortcuts are created manually by your users, but this is using the in-app promotion SDK enables you, the developer, to proactively suggest and implement Assistant shortcuts for your users. For example, at the end of purchasing our pizza from an example before, you can offer the user to create an Assistant shortcut So the next time they say, "Hey Google, get my usual pizza," the Android app opens the user's preferred pizza and it's ready to be ordered. An in-app promotion allows the developer to initiate the creation of an assistant shortcut by constructing a special deep link that has the app's own deep links and parameters inside of it. This is everything you need to know about app actions. Going back to where we started, app action consists of two parts: understanding the user's requests, which Assistant does and uses BAI in common intents, and then uses static or dynamic shortcuts to launch your app as a fulfillment to the requests, or you could use a widget for inline fulfillment for quick responses. And as extra, you can use in-app promotion for proactive engagement for your most critical user journeys. Users can jump right into the most interesting and useful points in your app with simple voice commands with app actions. Thank you. We would also love to hear from you, so share your feedback about this presentation by going to goo.gle/AOG-app-action-feedback. And of course, to get started, check out our docs, our new step-by-step guided code labs and pathways, code samples, and videos. Thank you.